Hi everyone. Can you hear me? Yeah, perfect. Hi everyone, welcome to my talk. Um, there's no doubt that PySpark has become extremely popular over the last couple of years, and it's now a go-to data processing framework. Um, as you heard before, like Romeo had a different opinion, but like for me, it's still the main one to use. And so we are going to talk about PySpark today. But let's first talk briefly about me. So my name is Przemek, and I work for a company called Market Finance as a data engineer. So we are a London-based fintech company helping UK businesses get access to a wide range of financial solutions like invoice finance and loans. Um, So part of my job there is to maintain our PySpark jobs. So we basically use AWS, and we have our data lake on S3. So we use Spark to transform the raw data that we have in our data lake in S3 and save it back to our data lake. So today I'm going to show you how we structure our PySpark application. So it's easy to deploy, maintain, and share with other developers. I'm not going to talk about how to write PySpark code, actually, or, for example, how to optimize the jobs. In fact, the jobs that I'm going to show here are extremely simple. And I'm going to show the ETL jobs here, but I know that other people here might actually be interested in machine learning code, which I believe it also can be used using this structure. So first, why do we actually need this kind of talk at all? So the answer lies on this image. So Spark is basically a cluster computing system, which means that it runs on a cluster of machines, and we need to deploy our code to all of the nodes of the cluster in order to run it. In case of single machine, we would probably deploy our code there, install dependencies using pip or other package manager, and then run our application code. With Spark, we need to find a way to actually run that on a cluster level. So here comes the Spark submit script to help. And the Spark submit is a part of a Spark distribution, and it's used to launch applications on a cluster. It takes care of setting up and distributing the code for us. So during this talk, I'm going to show a couple of Spark Summit options that can be used to launch our Python application. And in the jobs that I'm going to show here, I've used the movie lens dataset, which has the data about the movies and its ratings. So here we have the head of the movies file, and there are two things here I would like to notice here. The first one is that the title column contains both title and the year, and that the genre column contains the pipe separate lists. So these are going to be our two first jobs that we're going to use here. So the first one is going to create the two columns, title and year, and the other one, and it's going to have one row per movie, and the other one, is going to have a multiple rows per one movie ID, each with one genre per movie. So here we have our first version of the movies job. As I said before, very simple code. It has less than 20 lines. And what it actually does, it creates a Spark session, draw data from a movie CSV file, transforms it, like I said before, two columns, title and year, and then saves the data to in a Parquet format to some output location. And this is the other job, which looks very similar. And this is our structure of our application. So there are only two files there. So now in order to run this application, let's say movies job on the cluster, we are going to run our Spark submit script using the movies file So as I said before, very simple application, and it actually does what we wanted, but does it the way that we wanted? Not sure. So going back to our movies job again, first thing that I'm going to change here is there are some values that I want to export from this file to a separate file. And the first thing that comes to mind is actually might be our application name, but most importantly, I believe the input and output paths should be extracted to a separate file. So I'm going to create a separate config file, which I'm going to use, and here's how it looks like. This only has these 3 entries: app name, source data path, and output data path. And now I need to update my movies Py job. So what I'm going to do here is I'm going to read this file and create a dictionary, config dictionary, and then use this config dictionary in a couple of places to read, for example, the paths that we use here. So we already see that we could, like, the app is at least a bit more configurable. But what we've done now, we've added an additional file to our application. So we have this config file here, and now we actually need to find a way to send this file to our cluster. So we can do that using the files option from the Spark submit script, which can be used to add non-Python files to our cluster. In our case, it's a config.json file. Okay. So again, going back to our movies file, now we can see that we have a lot of duplicated code in this file, especially this like a boilerplate code at the top of the file where we create a config object and a Spark session. And this code is now duplicated in all of our jobs. We have only 2, but in the production application, probably it's more. So we are going to create a separate file that is going to contain this code and going to be treated as an entry point to our application. So what I've done, I've created a main Python file, which now, as you can see, it requires an input argument job actually, which tells the application which job to run. Then it has this boilerplate code here, so it creates a config object and Spark session, imports relevant job module that we need, and runs the module using the run job function and sends there the Spark config and Spark session and the config object. So in order to do that, to run the main file, I also needed to update the movies job. So I've actually separated this code into multiple functions. So we have a function to read the data from CSV, transform the data, load it, save the data to a Parquet, and of course we also have this run job function that is executed within the main file, and it's used to run the job. So now how our structure looks like. We have a new jobs package, jobs directory in our app, which contains our jobs, and we also have the main file. So now in order to run our job on a cluster, we need to first we need to run the main file and specify the job name as a job argument, and we have a new option which is PyFiles, which now adds our jobs as a zipped file to the cluster. But what happened now is that we need to manually zip the jobs directory in order to add it to the cluster. So what we are going to do, we are going to use a makefile, which basically is a make utility. So make is a utility that uses the make files to define the set of tasks that needs to be executed. I believe it was created to build C code, but has a wider application now. So this is what we are using, basically. So as you can see here, what we are doing is we are going to create a new dist directory in our application and copy all of the files there. And also we are actually creating this jobs zip directory as well. So now after running the make build command, we are presented with this application structure. And we can see that there's this new dist directory, which now basically contains everything that we need to deliver to our cluster. So it basically separates our code from like what we need to deliver to our cluster. And what's probably worth mentioning here is that this directory has been added to a git ignore, so it's not going to be added to our repository, as basically it contains the copy of all the other files that already exist there. And here's again the Park Summit comment, but this time we have the zip file from our makefile. So again, coming back to our movies job again. Now we've decided to that we want to separate the data operations, data files logic from the domain logic. So in this case, we have these two columns that we create here, and we probably would like to separate this logic from this. So what we are going to do is I'm going to create a UDF functions. So UDF functions are the user-defined functions that work on a column level on a data frame. So here I've created a UDF.py file, which contains these two functions, get movie title and get movie year, and it registers these two UDFs out of these functions. Very simple. So now I need to use these UDFs in our job. So here we can see that I'm importing the UDFs module that I've added inside the shared package. So basically it's inside the shared directory in our app. And I'm using this two functions here. And again, our application structure, we have the shared directory. And we need to add additional zip file to our makefile, and after running it, we have this additional file in our structure. So now in order to add this to our cluster, again, we use the same option as before, PyFiles, and we added a second file on the list here. Yep. Okay, but coming back to our UDFs file, maybe we've decided that slicing the string is not the best option in this case, and we want to use some other option. So I've decided to use a third-party package to run that. So I'm going to use a parse package in this case. So this is the new version, and and as you can see, I'm importing the parse package and then using parsing this title column using the template defined here. So now the issue is that the parse package is not a part of a standard library, and we need to install it separately. So we need to add a requirements.txt file to our application, which contains the packages that we need and its versions. So in our case, it's only a parse package at this time. And we are going to add this to our make file. So now we install the third-party packages inside our disk directory. In this case, it's going to be libs directory, which is going to contain all of the third-party packages. And I think it actually might be a good idea to use a Docker image to do that, because like some so we are sure that the version that we install, for example, locally, is actually going to work on our cluster. So we should probably use this like a Docker image that is compatible with our cluster. And at the end, we have again, we're zipping the libs directory into a libs zip file. And what's worth mentioning here that as opposed to shared directory and jobs directory, in here we need to zip the content of the directory, not the actual directory itself, because we want to use the package inside directly by calling it parse, not the libs.parse. So after running this is how our structure looks like. And again, we have a new zip file here. And again, additional file on the list at the end of the pile files. Whoa. So as you can see, our application actually changed a bit from the beginning, but there's probably one very important thing missing still. I think that we probably should start with, or at least add it a lot earlier in the process. Anyone fancy a guess? Yeah, so I meant tests in this case. So we are going to add some tests to our application, and here we have a test file that is going to test our movies job and one of the tests there. So what I'm using as PyTest as a testing package, testing engine, but on top of that, I'm also using the PyTest-Spark package that comes with the Spark session fixture built in, which basically simplifies the tests for us, because we already have this built in our test engine. And because the PyTest doesn't have the option to assert the data frames equality, I'm using the pandas testing package with its assert frame equal method. And I also have, apart from that file, I also have the another file that is going to test our unit tests that are going to test our UDFs. And here we have the version of our makefile after adding the tests. So we have a new two new receipts in this file. So now when we run the make command, bare make command or all, make all, for example, we are going to run our tests first, so we are sure that everything is going to work as expected, or at least we reduce the uncertainty of that. And here's our application structure at the end. And as I've mentioned before, we have the this directory, which is the one that is going to be deployed to our cluster. So how to do that? In our case, we basically use Terraform as our infrastructure as a code tool, and we use a CI/CD pipelines basically to deliver this code to our S3 bucket, where then this code is going, the paths to S3 buckets are going to be used by the Spark Summit in our jobs. Yeah. So now going back to the last quote of the talk, the code is read much more often than it's written, which basically means that the quality of the code is important. And as you saw, the first version of the application had 2 files as opposed to like more than 10 at the end. And the final application actually does exactly the same. It reads the same data from the same place. It transforms it the same way, and it saves the data to the same location. So basically, it does the same. But if the location of the input and output data is going to change, then we only need to change our config file. We don't need to change all of our jobs. If the domain logic changes, like for example, we've changed the way how we calculate the columns, we also change that only in UDF functions, not inside the jobs. We also added tests to our application, which makes it more secure to deploy to production. And we also created like this main file, which actually moved all of the boilerplate code to a separate file, which now makes it easier to create a new jobs. So in my opinion, even if the application at the end does exactly the same, I believe that it does it more in a more configurable way. It's easier to read and less painful to deploy. Thank you. Okay, so I've created a GitHub repository which basically has this code and has this application like splitted into all of the versions. And of course, we are hiring. So if you want to work for an exciting company in London, just check the website or let me know. Thanks.
Any question?
Hi, thank you for the talk, and everything is well explained. But can you please return to Docker magic? And yeah, as if I understood it correctly, you are running pip install inside the Docker image, right?
Yes.
Yes. Okay. How it helps us?
Because
How you then extract it, and you need a zip, right, to pass it to?
Yeah, so basically what happens here is, because some of the Python packages are, let's say, libraries, right, basically. So we might actually have a different, if you like run it on Windows, we might actually get a different version, or even like on Mac and on Linux. So the version that I'm going to pip install on my machine, and then I'm going to deploy it to our cluster, it might not work in some cases. So in this case, what happens here, it installs the everything that is in requirements inside this libs directory, right? And then it zips this libs directory because basically we need, if we have like some third-party dependencies, like in this case parse, but it can be like tons of different stuff. We basically need to deliver this code to a cluster, right? You cannot like install it on a cluster using like a pip or anything else. So basically, everything that is required for your application needs to be inside this libs direct. In our case, in libs directory, which then you zip and add it to the Spark Summit command.
Okay, thanks.
I have similar question because I wonder why you ship your libraries directly instead of using virtual, and Spark supports the virtual for some time.
Yeah, that's a good question, and I don't know actually. This is how we write it, and yeah, probably we should change it, but this is how it currently looks like.
Next question. Anyone?
It's a simple one. What AWS service do you use to execute your Spark jobs?
Yeah, we currently use Glue jobs, but we've also run this code on EMR. But we currently use a Glue jobs. So we basically define all of the jobs in Terraform, which basically runs the jobs.
And how do you configure then your clusters? Because you need to know how many worker nodes, master nodes, and all of that. So there must be a lot of infrastructure behind this.
We basically, like I said, we run it on a glue jobs. So basically, like a glue is like a managed AWS service, right? But of course, we can like tweak it a bit by like setting some of the PySpark options inside the glue job, exactly the same as running the Spark submit command, right? So the same as like I've added there like files and Py files. You can also define the memory, for example, right, on a cluster or number of nodes. Yeah. But of course, the glue jobs, they have some limitations in this case. So, but actually, we, like I said, we also run it on a EMR cluster. But for our purposes, it was actually easier for us to run it on a glue job. Yeah.
Is that because the jobs were small, or that they were more frequent, less predictable?
Yeah, we have like 200 of jobs like that. Were like very small. Yeah, maybe not very small, but yeah.
So I had a more general question about debugging information. So I know that if you run on a notebook, for example, which is sort of the go-to for a lot of people, you get a lot of information if there's an error, especially for a lot of rolling parts, like say you're using Parquet files, or you're just hosting on S3. But I actually really like your approach, and this is kind of the canonical, classic way you submit jobs to a cluster, and et cetera. But I'm curious about what sort of debugging information you get back with so many rolling parts. For example, with Docker, with actually the job submission to a cluster, where you're not using a notebook and things like this. Are you able to set up an environment very easily, say an IntelliJ or Vim or whatever, where you have easy to access information of when there's an error, when you're debugging, be the error on Docker or on the Amazon side, or on just the code side in general, say for the job actually running in some faulty Python code that's been written?
So I think there are actually a couple things here, but probably answering your question is that we are probably not good at that yet. So basically, we use as it runs on AWS. We use CloudWatch, where to like check the logs of like glue jobs, so Spark logs. But we also have the Elasticsearch cluster, which basically, but we only store log there like the start of the job, end of the job, and like error, something like that. So basically, like only to like compare that at the end of the day, we have like 200 that finished and 200 that started, or something like that. So that's it. And we also use a CI/CD pipeline, and we have some tests there, right? If, for example, something will fail in this make file, we would see it there, right? So CI/CD pipeline will probably fail on like a pre-deployment test, or at least on dev, before running the code to production, and we will basically stop the pipeline.
So in other words, if I understand correctly, it's just a more cumbersome coding. It's still more, let's say, difficult as it currently stands coding with this infrastructure than if, like you say, for example, we're debugging a single Python, just for simplicity, a single Python file that was loading some CSV that was like 10 megabytes.
Yeah, of course.
Yeah, okay. Yeah. Okay.
Last question. Is anyone? I don't see. Thank you.
Thank you.